Hey everyone, can you hear me? Let me know if you can hear me well. Welcome back again. Uh, let me know if you can hear me. If there's any kind of problem, if you can see me too, and all that stuff. Okay. So hi everyone. Hi Ronald. Hi Shimari. Hi Els Foros. Hi Green Joshi. Nice to see you again. Hi Mickey. Hi Shaneth. Hi Ronald. Ronald. Renachtu. All right. Yeah, there you go. Hi, everyone. Welcome back again to another Bubble Hack Week. So we're in Bubble Hack Week. I'm trying to look at this comment. Is that a Nia turtle? Yeah, it is. Yeah, so welcome back again. So we're on Global Hack Week, Machine Learning and AI Week. So don't worry about it. Don't worry if you don't have any kind of experience in ML or if you don't have any kind of experience in artificial intelligence. I'm going to try to make this as easy as possible. And don't worry about it. This is hard to me too. Like I'm not an expert on ML on AI, but I try to do my best on this. So don't worry about it. Like we're going to learn together. Uh okay, it's an axolotl. All right. Where do I live? Axolotls. There's like the natural place of uh, the axolotls, which is Xochimilco, and Xochimilco is like a really nice river or something like that, like a lake where all the axolotls live. So yeah. So welcome everyone. So if you're curious, well, you already see the title. We're going to learn how to create our first image classifier app, and after that, we're going to learn some new stuff that we want to do today. All right, we're going to create this image classifier. We're going to use like the most common usual image classification example, which is the MNIST dataset. That is basically a dataset of some kind of numbers. So don't worry about it if you never have used this before. So yeah, why don't we get started with this? So let me just share my screen first, and then we can just jump into this. And after that, we can begin working with our example. So give me just a minute and create your first image classifier. And there you go. Oh yeah. So let me know if you can see my screen and just let me put my slides here. I think yeah, they're loading. Alrighty. So there you go. I think you can see it now. Can you see it now? Give me just 1 minute to just yeah, there you go. Uh you can oh yeah, all right, yeah. I was afraid because I was seeing it like right on the stream, but because I wrote David like that you couldn't see the my slides. I was worried, but yeah, let's just begin. So welcome everyone. If you haven't ever seen me here on the MLH, my name is David. You can call me David, however you want to call me. I'm fine with that. I'm David or David. I'm from Mexico. I'm a Mexican coach with Alberto, which is the other Mexican coach. Well, the other coach in Mexico. But yeah, my name is David, and I'm currently a coach at MLH. I also work as a software developer engineer at AspenTech. I also work on communities as a GitHub Campus expert. I'm the founder of one real cool hackathon here in Mexico called Tigre Hacks, which Tigre is like the Spanish word for tiger. And you can see here that there's like a little cute tiger here. So yeah, it is Tigre Hacks, and also I really love being in hackathons, being in hackathons communities. I love the community here in hackathon. I'm from a state in Mexico called Veracruz, but I studied in another northern state called Monterrey, and now I'm living on Mexico City, which is the capital of Mexico. So yeah, I was also once upon a time 2 years ago an MLH fellow at Meta at the 2022 Summer Production Engineer batch, working at Meta as a production engineer. I really love it. It was super awesome. I'm also in a really cool machine learning group, like just a bunch of people is there. It is a really cool group of my friends called ML Cats, and it is called like that because most of us do machine learning, or data science, and things like that, and every one of us love like cats. So if you're an ML cat, it's in you. Yeah, thank you so much. Yeah, and yeah, so currently I'm building a taxi startup. I also am building a research a tool for the persons who are doing research now, and I'm doing some weird stuff that I don't think I'm able to talk about it. But yeah, that's me. I'm so glad to be here, and I'm glad to be your coach in this kind of streams. So let's begin. So first thing, what are we going to do? We're going to learn the basics before trying to do our stuff. I saw a message that said, which kind of stack are we going to use today? So we're going to use a notebook that is already um, prepared for you, so you can just follow like the instructions. Well, to be honest, it don't have any kind of instructions. I made it like that so you can see watch the stream and don't go like further from the stream. So yeah, it is a notebook. We're going to use Python and we're going to use TensorFlow. We're going to use TensorFlow, OpenCP. We're going to use also a real common dataset called MNIST, which is like a dataset of images of numbers, and we're going to try to classify a new number inside that. So yeah, so well, let's begin. Let's just first understand the basics. This is bad. This is not right. This should be uh, image classification. Let me change that. Image classification. Yeah, there you go. So yeah, what is image classification? So image classification is just a task that we use in computer vision. That computer vision is one of the fields of machine learning or artificial intelligence. Well, it is not inside machine learning at all. It is mostly like inside. It is like separate fields of artificial intelligence, and one of them is computer vision. So yeah, in computer vision, we have a task that we call image classification, where basically image classification is like a kind of algorithm that we use for train and categorize images into predefined classes or or categories. Sorry, and the goal is to teach like our computer in a kind of way that the computer understands the data that we're passing to our computer, how to recognize and distinguish between different objects or patterns within an image. So in a really cool example, it would be, as you can see in this image, we have like a cat and also we have a dog, right? So the image that our task as engineers is like to try to teach the computer how to differentiate or try to identify, hey, this image contains some kind of patterns that say to me that this is a cat and also this is a dog, or this kind of new thing that I never seen before is some other thing. All right. So yeah, and there you go. So this is simply a sheet by fitting like our model, our really large data set of label images, where each image is associated with a specific class level. So for example, we can see here that we have on the image 3 levels: a cat, a frog, a duck. And in our level data, we have like different cats, different frogs, and different ducks that we are here. So during the training process, our model is going to learn to identify features and patterns within the images that are indicative of each class. And once that we train this model can then be used to predict the class of a new and seen images within a certain level of accuracy. So what this means is that, for example, in the cat, frog, dog example, the first thing that we do is to pass a really large data set of information, and this information can be like just a bunch of images, of images of frogs, a bunch of images of cats, and a bunch of images of dogs, right? So we're going to train a model to try to identify uh, which kind of uh, to try to so our model can identify what is a dog, what is a frog, and what is a cat. And then we're going to train a model with that kind of information. And if we pass like a new kind of animal to our prediction or to our test data, we can have a lot of ways, or we can have a lot of cases. So in this kind of cases, our model is going to be already able to predict if the images contain a dog, a cat, or a frog. So in this example, we're using imagine that we're using a different kind uh, of cat and a different kind of dog. Like for example, we train our data with something like data set of images of Labradors or like golden retrievers. And if we pass image of a Chihuahua, our model should be able to identify that, hey, this is a Chihuahua. This doesn't look a lot uh, like a cat, but also it doesn't look like a Labrador or like golden retriever. So I'm going to pass you some kind of probabilities. This image that you have passed me, maybe 10% a cat, maybe 0% a frog, or it may be um, 80% a 80% a dog and 10% others. So yeah, we're always going to have like something like kind of 100%. So sorry for that. Oh, well, I'm dying. Yeah, so yeah, we're always going to have an answer whatever we pass like an alien, or if we pass an image like an avocado or something like that. We're always going to have an answer. That's a rule. So why is image classification so important? So it is important because we are using, actually, like today and this times, we're using image classification in all the industries, in all the branches that we have of science. So, for example, we are using image classification for medical applications, for identifying our abnormalities in medical images, such as X-rays, MRIs, and CT scans. It also can be used for detecting tumors, fractures, anomalies, and other medical conditions that our patient can have, and that help doctors and the persons who are working in healthcare to make a better to bring a better service to our clients, right? And also, we're using it on remote sensing, which remote sensing is like a like satellite images that we're using for detecting maybe erosion, maybe segmentation, maybe superimposition, or maybe what is happening, like in which parts of the world are we having like um, bonfires that are burning like complete fields and things like that. So in fields such as environmental science, agriculture, and renewable planning, image classification is used to analyze satellite and aerial images. So this helps us to monitor the land that we use, to assess the crop health, and also to detect deforestation and managing natural resources. So a real cool example there is that we can see here is that in some research projects, image classification is being used for try to predict um, which kind of how the deforestation of the current forest that we have today is going to affect it's going to affect us in the future. Maybe sometime, because of the deforestation, we can have um, some kind of problems near my city or near some kind of cities and things like that. It is super cool. I will totally recommend you to try to look at remote sensing projects. It is super awesome. Also, we're using it on security. So image classification plays a crucial role in security and surveillance systems by automatically identifying objects, people, or activities of interest in video streams or still images. So if, for example, maybe I can have an image classifier for passing from my camera to my server, like a model that can predict if there is someone inside my house or something like that. And with this, I can have another application that can tell me on my phone or something like that, the amount of persons that are on my home or something like that, or if there's a person that I haven't never identified, so that is a stranger, that is an intruder. If I recognize the faces that I'm seeing by my camera and things like that. It's super complex. It is super cool, to be honest. I will totally um, encourage you to take a look to these kind of topics. It is super cool. So yeah, let's just continue. Another cool example that we saw the other day on the which one? I think it was on the introduction to NLP. Was it there? No, it was on the introduction to RAG applications. So in the string, we saw like what were the embeddings that the RAG applications uses. So one kind embeddings are super important for this kind of topics. For example, autonomous vehicles. So in this kind of fields of the development of autonomous vehicles. Image classification enables vehicles to recognize interpreted traffic signs, pedestrians, cyclists, and other vehicles on the road. So as you can see in this image, we have like a movie car that like we have already detect that we have moving cars, stationary roads, pavement, and things like that that are super cool and that we can work with them. Also, we use them on retail and e-commerce for detecting like analyzing which are the customer preferences, like if some product is being um, sold more than other ones. Also provide like information to my shop to see which kind of parts of my shop are already empty, which kind of products are the customers buying more, and things like that. That's super cool. Also, it works in the industry as quality control on manufacturing. So we use that we use it in manufacturing industries for identifying if we're enabling quality into our products. So in this kind of industries, we need to detect if our products have any kind of defect, or if we're having like the constant, like the same quality consistently for each kind of product that we have into our manufacturing company. And such as for example, if we have in this image is basically like the example of how the computer is recognizing that a hole is being detected inside our t-shirt, or if we're manufacturing t-shirts or things like that, we can identify if there's an error by just training our data with all the t-shirts that we're going to use. For example, this one is a gray t-shirt, but we have found that we have like a wide hole that it doesn't recognize, or well, my data hasn't been trained for recognizing that kind of colors, that is an anomaly, and maybe that is something bad or something that I'm not expecting from a product. But yeah, so how does image classification works? So it is a real big process that we need to learn. The first one is that for training a model to classify images, the first thing that we need to do is to collect data and process it. So this can be any kind of data. Well, not any kind of data, but any kind of data collection of images. So we pass a great. So we gather a large data set of images with corresponding labels. So, for example, the differentiation between a baby, between a cat, between a dog, between a woman, a man, and things like that. We're going to pass this kind of data sets to our to our environment, and we're going to train our model with that. So these images should represent different classes or categories that we want our model to represent. So it is important to have labels on each one of them. So yeah, as I said, it is a really big process, or well, it is super big. Like in this photo, we can see that it is not that big, but this is not like the real life. In real life, this is like a cycle that we're always going to transform our data. We're always going to transform like the things that we're training with our model to do, and after that, we're going to try that model to see if the data is correct, and if not, we're going to retrain our model to identify in a better way, or like I don't know, a baby, a cat, a woman, and things like that. So the first step of this is the data completion, which is like bringing all the pieces of your data set that you need for classifying or for preparing your model to for training or for classification training. So maybe maybe you have a data set of images of babies, but you have a data set of images of a man or woman and things like that, or yeah. So the first thing is to bring up all the data sets and all the images that you want for your data set to have. And let me just quit this comment so you can see the screen better. Yeah, is that better? I'm getting to see that is better. But yeah, yeah. So after that, the only thing that we need to do is to reduce the noise in our data set. So what is noise? Maybe in our, so data can be shown in a lot of ways. not all the images have the same size. Maybe some images are going to have a lot of noise, are going to be really blurry, and we don't want that. We want images that we can that our model can we want images that our model can use for identifying features or things that like patterns or features or things like that bring information to our model. So I don't know if that is more clear, but yeah, basically we're going to filter these images or we're going to take them out. We're going to call all these images like trash. So we're going to take out all these trash images and we're going to put it on the garbage, and that is why this step is called data noise reduction. But yeah, so after that we're going to transform our data by doing implementing some mathematical techniques for our model to identify it. So remember, this these are just images, and yeah, like our computers can identify images, but not really. Like it can identify pixels, or an image is just a bunch of pixels. So basically, our model is able to identify pixels and colors. Remember that we have some kind of color systems that we can use for creating some kind of colors, like the RGB, the RGB, yeah, the RGB uh, color, color code. So we can use those kinds of information for our computer to identify like patterns and things like that um, for our image classifier. So after that, we have our data reduction, which data reduction is like just taking out like data that doesn't bring me a lot of um, that doesn't bring to me a lot of information. And yeah, basically after that, we're just going to validate our model. And after validating our model, we're going to try to bring our model to the real life. And after bringing our model to the real life, we're going to try with some other examples. So yeah, let's just continue. So yeah, I mentioned our really interesting word that is called feature extraction. So this feature extraction is basically trying to identify features from the images that we have, or identifying or discussing these between different classes. So this is the specific function because it represents the visual information in a way that the model can understand. So yeah, as we can see here in the image, we have like a cool kitty, like two cool kitties that we have. So the task of feature extraction is to basically just take that image and try to identify some kind of features that we have here, such as like the like we are seeing that cat's mouth have some kind uh, of patterns, or of pixel patterns, such as like the color, the form, and things like that. So we want to identify those kind of features and coordinate them with some kind of mathematical things like geometric feature net and local geometric feature and things like that. And what we want to do is to trying to train these features, or like trying to identify these features so our model can identify them. We're not going to see like the math behind that because explaining that will take a lot of time. But yeah, we're just going to continue and we're going to assume that we're cool with that. So yeah, so common techniques for feature extraction include using pre-trained convolutional networks such as BGG, ResNet, Inception, which help learn to extract a hierarchical feature from images through training or large-scale datasets like ImageNet. So yeah, we're just going to do that. So the question is, are we going to hack now? Are we going to build our image classifier now? And the answer is no. We need to learn some more stuff before continuing, like for understanding and having the whole context. Uh, and we also need to implement some things like trying to understand how the model's training works, the validation, and the inference. And also, we're going to learn how to use some libraries like TensorFlow, like OpenCV, and things like that. And after all this stuff, we're going to continue with that. So yeah, let's just jump into model training, and also let me know if you're sleepy or something like that. Like which time is where you are at right now. For example, where I am is like 5:32 p.m. Yeah, but I know that some folks for India, um, think it was IST. Is it IST? IST hour. There you go. Yeah, I know that in India it's like 5:02 a.m. or something like that. Oh, are you from West Side, Green Joshi? Oh my God, 1:32 a.m. Where are you from, Elahani? Is it Elahani? Yeah, I know that in India we're some kind of hours behind. But for example, in the Indian Standard Time, I think it's 5:02. Oh my God, Egypt! Greetings from me to Egypt. Wow, so cool. Okay, let's continue. So yeah, a model training. So for training a model, we're going to do a lot of process like the ones that we are seeing now on the screen. But yeah, so the only thing that we need to do is to choose appropriate classification model architecture, such as the convolutional neural networks, and to train to process data. Sorry, in this stream, we're not going to learn the deeply what is a convolutional neural network. So yeah, don't worry about that. So yeah, during the training, the model is going to learn how to map the input images to their corresponding class levels by adjusting its internal parameters or weights. And based on the provided training examples, it is going to try to select a column or to try to make a prediction with that. So after that, we're going to train our model. So by training, we're going to have our data set and we're going to use only 80% or only 70% of our data set to try to train that. And also we're going to use the other 30% of our data set to validate our data set and for pre-process other stuff. Yeah, we're going to use an ML processing pipeline, and we're going to use this algorithm section. By this algorithm selection, we're going to fine tune our model, and after fine tuning our model, we're going to evaluate the training model in this other test set that I told you about that we're going to use for testing our data set. So yeah, this is an example of the thing that we're going to have today. So we're going to use this data set that I have right here. Let me pass it. Oh my God, I just closed it. Uh, Let me search that again because I just closed my window. Where are you at? Blah, 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 blah. There you go. Let me pass you by chat. And yeah, there you go. Let me read the chat. Let's see that there's a lot of activity. So it's 6:32 p.m. Germany. GMT 6 Mexican City time. Yeah. Green Yoshi 4:32. India. Also, you are from the west side. Are you from California or something like that? Or are you from somewhere near California, from Nevada or like that? Um. Oh. Yeah, that would be awesome. Uh, oh my God, is Arizona really coming in triple digit temperatures? I think the most highest temperature that I've ever been was like 48 Celsius degrees. Uh, the hottest temperature that I ever been is this one on my state in Mexico. So yeah, it was a really hard day and like everyone was sweating and all the stuff. But yeah, let me know if like also is Arizona snowing currently? That is so cool. Uh, nice, awesome. Uh, nice. Okay. Yeah, let me do that. Yeah. I was just reading the comments. Sorry for that. I was trying to understand what you were talking about. And yeah, looks like we're having people from Egypt. Yeah, yeah, that is hot. Yeah, I know that is hot. Yeah, I was just reading the comments to say where are you from. So looks like we have people from Mexico, from Egypt, so people from Arizona. Yeah. Oh my God. Wow. So yeah, let's just try to continue. So I just passed you this data set that it is on the Twitch chat and also on the YouTube chat, so you can take a look if you want. But basically, uh, what this data set is like a bunch of images of 32 by 32 of numbers, like from 0 to 9. So let me just share it with you, like what we're going to see. So I think that you're seeing it now. So basically, this is the MNIST dataset. Basically, it is a database or a dataset of handwritten numbers, and these handwritten numbers you can identify them by just well, you can easily identify them. And like our task is to use some kind of random number that we're going to pick from this kind of data set, and our model should be able to identify if this new number is a 0, it is a 1, 2, 3, and so on, so on, so on, until we find like the correct one. So yeah, this is what we're going to do today. And also, I'm not going to explain so much about that, but what you need to understand is like images are pixels, and pixels are arrays of bits. Yeah, they're like arrays of numbers or activated bits. And this one, we can see an example that we have a number here, like the number 3, and in this number 3, we can find two different colors, right? A white one and a black one. So we're going to identify all these. We're going to identify like the black colors as 0 and the white colors as 1, or like you can do it like vice versa. We can use like black ones as 1s and white ones as 0, and yeah, we can just continue with that. So yeah, we can use this array, and we're going to choose some bunches of this array, and we're going to patch it like in a 9 pixels array, not 3 by 3 matrix array. And is this the concept? I love snow, and oh my god, that'll be awesome. If you want to share some pictures, you can use the Discord server to share the pictures so we can see like the snow that it is like out of your house. So it would be awesome. I think here in Mexico it doesn't snow that much, but when it snows really, really, really bad. So for example, there's one place um in Mexico called Barrancas de Cobre, which is like um, some kind of mountains part of Mexico, and we have a really cool train that is called El Chepe. So yeah, when you like, it is like the Polar Express of Mexico. So in December, January, it is no so much in those parts, and we have some kind of awesome views in this kind of forest. So yeah, it is super cool. It is super awesome. I really love it, and it is one of my yearly goals to go to this train and to see like the snowy places. So yeah, it is super beautiful. I really love it, and I really want to go so bad. But yeah, yeah. Sorry. Let me just continue with this. So yeah, we were talking about like the images, and we're going to use a 32 by 32 input image, and this image is going to be like basically an array of zeros and ones, where the activated ones are going to be the ones who are in a white color, or that we identify as a white color or as an activated bit, and we're going to basically filter this. We're going to make like a filter with a color now that I'm not going to explain today. But the only thing that you need to do is that we're going to filter some kind of parts of our image to try to bring us some kind of numbers, and with those numbers we're going to pass it to the convolution to the our CNN convolutional neural networks, and they're going to bring us like a number, that this number is going to mean something. And when I mean something is something, I cannot explain it because it has a lot of math behind. And if I try to explain that, it's going to take us the whole class. But yeah. So yeah, and after that, we're just going to make validations and fine tuning. And for doing that, we're going to validate our trained model in a separate validation set to assess its performance and generalization ability. So this helps us a lot for detecting overfitting and tuning high parameters to improve performance. Here's a really cool word that is overfitting. So what overfitting says, what do you think? I want you to make a question. What do you think if we have a data set, for example, of cats and dogs, but for example, the our labels of cats, we have like 1,000 images of cats, and for dogs, we have 100,000 images of dogs. What do you think is going to happen? The one who answered me correct is going to win. Mm, what can we set? Yeah, there's unbalanced data. Okay, oh, Hanny, I'll think what to bring to you. But yeah, there's going to be unbalanced data. We're going to have more data, one data set of images greater than other. So yeah, this is exactly what can happen. Because our model has more information about cat images, or our model have more information about dog images, it was going to maybe detect cat as dogs, or it can detect better uh, dogs than cats. And also, if we pass something new to our image, is going to um, is going to make predictions that are going to be better for dogs than for cats. So, for example, maybe I will pass something new like an avocado, and it detect this avocado as a dog, like 80% dog, 0% cat, and we don't want that. Like in the real life, we want our model to be able to detect new things. Yeah, yeah, yeah. Don't worry about it. It was super correct, and you were like the winner of the questions. But yeah, if we go to Amazon Web Services, I really love like the concept that they bring. Um, Overfitting, it is an understandable machine learning behavior that occurs when the machine learning model gives accurate prediction for the training data, but not for new data. When data scientists use machine learning models for making predictions, they first train the data model on a known data set, and then, based on the information, the model tries to predict outcomes from new data sets. An overfit model can give inaccurate predictions and cannot perform well for all types of data. And let me see if there's any kind of image that no, it is not. So let's just try to search an image of overfitting, and there you go. So we're going to imagine that we are going to have a curve, which is going to be this curve of like some kind of classification curve. And what we want to do is our curve to be like super curvy. And in overfitting, what happens is that our curve is not like that. We have like an overfitting curve, like super wavy, and that means that our image classification model is not correct, and it's going to be predicting things as something that we will don't want. And overfitting image classification, there you go. Maybe when we pass this, we're going to have some kind of problems about the doggy that we're seeing. I really love the image. It is super cute. It's adorable. But yeah, yeah, exactly. Overfitting is an issue that the model can decide the output due to is familiar with inputs he's trained on. So the model is going to have a lot of problems with this. But yeah, this is basically overfitting. So this is why we use the validation and fine tuning. The validation part of the the validation part of our model is going to detect if we have some kind of overfitting and tuning into our tuning hyperparameters to try to improve our performance. And the fine tune is just trying to retrain our models by adjusting its architecture, optimizing their settings, and learning new things from new things that we have to detect from our own. So maybe one time I'm going to detect that uh, maybe I'm identifying that avocados with this kind of colors are being detected as cats. So maybe I need to pass avocados or like trying to train my data set with avocados, but in different angles or things like that for having better performance and for having better predictions of this. But yeah, we're going to learn this, and also we're going to incorporate it with our some kind of regularization techniques to achieve better accuracy and robustness. So yeah, you can see here like a graph that we have here. So this graph have like the thing that we are doing. So also the first thing that we're doing is concept law modelization. Uh, we're going to program to try to compute our model, and this computing is going to convert into a computerized model, which is going to be our model we already trained, and we're going to pass that maybe for to an API or something like that, so our model can learn how to predict the thing that we have just passed to our model. So after doing this, we're going to simulate. Oh yeah, sorry for that. Yeah, is that better? And also let me zoom a little bit. Let me zoom in into this thing that I don't know how to. Oh, there you go. Oh, how can I zoom? Actual size. With the screen. Can I do better like than this? I think I cannot. Oh well, let me try something. Oh, full screen. How do I do full screen here? There you go. So, oh, what is going on? Yeah, I don't know if it's the thing I want to do. Oh yeah, you were seeing it. Yeah, that is better. I'm going to assume that that is better. Yeah. So yeah, and basically when we already had this in passing to our when we're already passing it to our API, we're going to assume that we're already on the real world, and maybe I'm trying to detect in maybe I'm a agriculture and I have an avocado plantation, and what I'm going to do is to try to predict if my avocado trees have already mature avocados that are ready to eat, or ready to be sold to this kind of retail shops and things like that, right? So maybe it doesn't recognizes the green avocados or avocados that have maybe red colors, or if these avocados have some kind of issues and things like that. So what we're going to do is to fine tune our model. Well, first validate if our model is doing a great job, and trying to learn how is the model doing, and by learning this and by having rating techniques of our model, of how our model is doing, we're going to fine tune our model to do better, or we're going to analyze if our model has some kind of issues where we have overfitting issues and things like that. So after that, after analyzing, we're going to reprogram our model, and after reprogram model, we're going to computerize it, and after that, we're going to simulate, and so on, so on, so on. It is a cycle that we need to learn to use so we can have better models that make better predictions without the without making making our company or making us like as a scientist um, make bad predictions for real world things that we're using. Okay, so until now, we are finished with all the slides. We're going to hack now. And let me pass you some kind of things that we're going to use today. And the first one is a library called TensorFlow. So if you haven't heard of TensorFlow, TensorFlow is a really cool, also let me change this to English. Yeah, there you go. TensorFlow is a really cool machine learning framework that Google uses. Other thing that we're going to use is OpenCV. It is a computer vision library that we're going to use um, for our hack today. And the other thing that we're going to use is, let me see, it is Matplotlib for trying to plot our library. We're trying to plot our photos or images that we're going to use today. All right. So before beginning and before explaining all the stuff, uh, does anybody have any kind of questions? Is like the concepts explained today clear? Do you have any doubts or things like that? If you do, don't mind to bring it up to the chat. And if not, I'm just going to continue the I'm just going to continue with this, but before continuing, I'll need to drink some water because I'm dying. So I'm dying of thirst, and also I'm going for some coffee. So is that okay for you? And what do you think if we come back at 6 p.m.? Well, for me, 6 p.m. Well, I'm going to come back in 5 minutes, and after that, we're going to begin with our image classifier. Before I go, let me share with you the notebook. Any user can use it, and any user can be, yeah. So I will pass you this. All right. So I just pass you this. I will pass you this collab notebook. What you need to do is just get into this collab, then go into file, and then get in. Well, first sign in into your Google account, and after that, get into file, and then save a copy in Drive, and after that, everything should be ready to go. All right. So while you do that, I'm going to stop sharing my screen and just going for some coffee. All right. Yeah, thank you so much for being here, Mickey. I'll appreciate it a lot. I hope that you learned something. But yeah, have a good rest, stay safe, and I'll see you another time. And yeah, I'll go for some coffee and I'll see you in 5 minutes. Bye. Mm, yeah. Hey, hi everyone. Mm, so I'm back. I hope that you have your glass of coffee, glass of water, your cup of coffee and glass of water. So let me see. Oh my gosh, Amari, this those photos are amazing. Wow, that looks super awesome. Super awesome. Mm, okay. Hi, Adi Suyash. Adi Suyash. Is it Adi Sudash? Adi Suyash. Adi Suyash. Yeah, I think it's Adi Suyash. Hi, Adi. I'm going to call you. Wait, is that okay? So, hi, Adi. Hi, Shamari. Hi, Ella. Hi, Honey. Hi, everyone. Welcome back again. So, yeah, let's just continue cooking. Mm, so, yeah, first of all, remember that I just passed you the collab that we're going to use today. And yeah, so let me share my screen just to pass you. Mm-mm-mm. Huh. Okay. Okay. Give me a minute. I'm just trying to check something. But while I'm checking that, I'm going to share my screen and there you go. hmm And yeah. Uh Let me know. Oh, I need to change this here. Uh-huh. Yeah, there you go. And I'll make some little bit of zoom to this. Let me know if this is more than enough zoom or if you need more zoom. You need me to zoom more into the clock thing. And yeah, let's just try to do that. So let's begin by so first of all, welcome back everyone. Uh, mm, mhm. Yeah. So first of all, let me know if you're already here in the collab notebook, and I'm going to wait until someone tells me that it's already in the um, into the notebook, so we can continue. All right, all right. So let's just start first. So the first thing that we're going to do is to install our dependencies and our setup. So as I pass you some links so you can get into the libraries that we're going to use. The libraries that we're going to use are TensorFlow GPU, OpenCV, Python, and Matplotlib. And so yeah, Colab is kind of, if you have worked ever with Jupyter notebooks, it is super similar, but you can work this and share this thing with other persons. So the cool thing about Collab is that also you can use your own terminal here. Like you can have with this thing. Well, this is for Collab Pro only, but yeah, you have a lot of tools that can help you like with your applications or with model training and all the stuff. So yeah, let's just do that. And while this installs, let me just talk a little bit about TensorFlow and what are we going to use in TensorFlow. So TensorFlow GPU is where? So yeah, mainly TensorFlow is already installed in your collab and probably the GPU too. And yeah, okay, so there looks like there's an error. Python setup like blah blah blah. So process downloaded TensorFlow GPU. Yeah, don't worry about it. To be honest, um, yeah, don't worry about it. And also, the only thing that we're going to do here is to see all the packages that we have installed into our collab. So we can see that we have a lot of packages. And the only thing that we want to see is TensorFlow. So let me go here into the T1. I'm searching. Um, TensorFlow. There you go. So we have TensorFlow datasets, estimator, help, IO, blah 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 blah. So don't worry about that. And also, after checking this stuff, is everything is installing, the only thing that we're going to do is to import TensorFlow. And I think I'm missing something else. Let me see. I'm missing something. Um, Well, yeah, we need matplotlib and to import numpy as MP. And let me do that here. Let me change this and import numpy. So yeah, we're just going to import numpy, and also we're going to import matplotlib as matplot. And also we're going to add um, other block code here. So to add other block code, the only thing that you need to do is to put your mouse like right here, and you're going to see something like code and text. So we're going to add the code block line, and we're going to add the next word here. And why are we doing this, or what does this line of code means? The only thing that we're doing with this is we're indicating to matplotlib to render this stuff, where to render all the plots of the pictures and labels inline. So if that makes sense, I'm going to continue. Mm, all right, I'm going to send that it is. And yeah, um, and another thing that we need to do is to I'm trying to look at the, yeah, we're doing that. We're also doing that. Yeah. So mhm. The only thing that we're doing here in this line of code is to avoid some kind of errors by setting our GPU memory consumption. So the only thing that we're doing is to configure our TensorFlow. So we're doing TensorFlow config experimental list physical devices and GPU. And if we don't have a GPU in our computer, so if we're running this in a computer that doesn't have any kind of GPU, uh, in step 3, trying to look at where is the step 3. Look that up. Oh, there you go. Nice. All right. So if we have that, I'm going to quit this here. And yeah, thank you so much for letting me know as far as, yeah. And the only thing that we're doing after doing that is that we're checking, hey, do I have some devices or some GPU devices? So if we have, then I'm going to store all my devices in this variable. And for each GPU that I have, I'm going to set my memory drop to true. And after that, I'm going to list my physical devices. So this list of my physical devices is going to show me the kind of devices that I have here. And after that, we're going to import CV2 and image HDR. This is for just detecting some kind of stuff. But you know what? What I'm thinking of is that we need to load first our minced images. So for doing that, what we need to do is to use some library of TensorFlow. So we're going to ignore this kind of stuff here. You know what? We're going to delete this. We're going to delete this because this collab notebook that I passed you is built for other type of images that are not the ones that we're going to use. So the thing that we're going to do now is to import Keras. So we're going to do something like import Keras, and the MNSD. That's it. So for doing that, what we're going to do is to use another line of code called tf.keras.datasets that MNS, yeah, there you go, MNST. And I think for doing that, yeah, that load data. And what is just going to return us is um, two tuples, and each tuple is going to have some kind of information that we're going to have inside those tuples. And what is that information? Um, there are those are going to be two data sets. The first one is going to have as one value called x train, comma y train, and the other one we're going to call it x test and y test. And remember why we do that? And we're doing this because this is going to happen to bring us yeah. uh, Also, I think I'm going to remove this because I think I'm not going to use it yet. Let me think. Am I going to use it? No, I don't think so. So I'm going to remove this. Um, so the only libraries that I installed now, or yeah, the only libraries that I installed are these ones, and the ones that I imported was TensorFlow, STF, and OS that is going to have access to my system. And after that, I'm going to load the MLM and IST dataset by this function, which is tf.keras.datasets.mnist.load data. And this is going to pass me two datasets. And these datasets are going to be our training dataset and our testing dataset. And this X train is going to bring me um, is going to be the data of those data sets, and it's going to be split between um, these two training sets, and we're going to see the shape of each one of them. So yeah, let's try to do that. And for shaping, we're just going to print the shape of each one of them. And for printing this, we're going to do something like X training original shape. And it's going to be yeah, like this, and comma x shape x train dot shape, and we're going to do the same thing for the original shape of y. So we're going to do this, and what we're going to see with this is, let's see. Oh yeah, sorry for that. Shouldn't use this. There you go. So we have imported our Keras dataset, and we can see that the training original shape of our X X shape has 60,000 yeah, elements in 2028, and our Y training data original shape is going to have that. So what we're going to do now is to separate this into other cell that we're going to use. Yeah, totally. Yeah, I forget about that. So let me show you what is Keras. Yeah, I think you can see it now. So what is Keras? So Keras is a really deep in context, deep learning library that we can use. And the cool thing about Keras is that TensorFlow already uh, brings Keras inside its package of TensorFlow. So we can use Keras for whatever we want. And Keras is being used in a lot of things. So for example, we can see that Keras is in CERN, in NASA, NIH, in a lot of places. So yeah, Keras is super cool. It is a deep learning library that we're going to use, and we can install it by using pip install aggregating Keras. But if we are working inside our Google Colab, we can use Keras like super easily by just importing TensorFlow. And yeah, so basically it is just a machine learning, deep learning library that we're going to use for training our data sets and like understanding what are we going to do. Let me go again. I think I lost this. Where did I put this? Give me a minute. I think I closed. Yeah, there you go. Yeah, I'm sorry. I think I closed this. But yeah, basically, we're going to use Keras for um, importing our data set inside um, our terminal or our notebook. And after doing this, what we're going to do is to create a new loop. And to be honest, I think we're not going to use any of this stuff today. Yeah, I think I passed you the wrong notebook. But yeah, basically, we're going to continue with that. All right. Oh yeah, I see where yeah. Sorry for that. I okay, yeah. Um give me another minute. Just give me a second and yeah, let me see if there are some comments in the stream. Yeah. Mm, and yeah, we can continue with this. So yeah, so what are we going to do now? The only thing that we are going to do is to okay, we have already imported everything. So before preparing the dataset, we're going to look at some samples of our training data. And when approaching to machine learning problems, visualizing data when it's possible is a great thing to do since it gives us useful insights. So we can use, like we can reach this task by using matplotlib, which is a Python library that allows us to create simple plots and images for mathematical data like the one that we're looking at. Because by just seeing the shape of this stuff, like some kind of hard, so we're going to see like this. And how we're going to do that? We're going to do that by seeing all the stuff that we have in this data set. So for doing that, the first thing that we're going to do is do a for loop for I in range of 9, and we're going to plot this stuff. But I think, yeah, let me import first this and changing the place of this, like right here. Yeah, there you go. And I'm going to run this in my plotted line and also GPUs. And after that, yeah, we're going to use plot that subplot 3, I plus 1. And I'm going to explain this in a minute. Just let me finish writing this. It is x train of I, and then the C map is going to be gray, and the interpolation is going to be equal to the interpolation is going to be in known. And then the plot title is going to be, I don't know, something like class this, and the format is going to be Y train of I. And then we're going to use another stub called plot that side layout. And let's see what this does. Oh yeah, I think side layout. There you go. So yeah, let's just try to explain why we're doing this. So, so first of all, the plot image show function converts digit matrix and of all the images that are stored as matrices. So we can imagine that we're converting a matrix in something that the matplotlib library can use. And if we try to see how the raw data of the image looks at, is going to show us something kind of funny. We're going to see it later. But yeah, basically what we're doing is that we're saying, hey, in a range of 9, of 9 digits, which is like the size of our image that we are trying to plot. Create a subplot called for each third pixel, and try to plot this into our image show. So plot for each x train of I that you're seeing. Sorry, it was sorry. Yeah. I think I got a little bit confused. But yeah, what we're doing is that we're having a matrix of 9 by 32 by 32, and we can see that by just doing this. Let me do that. So yeah, this is like raw data that we're seeing of like our current images. So we can see like the shape of each image that we are seeing. So we have a 28 by 28 image, and this 28 by 28 is a matrix that we're seeing, and each vector that we're seeing here is like the matrix that we have. So for example, this first vector that we have here, well, we see that we have a matrix, right? This is the first line of the matrix, and then we have each vector right here. So this is the first one, then we have the second one, and so on, so on. So what does this mean? Like in the first line of the images, we're just seeing zeros, and then we are seeing zeros again, blah, 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 blah. And after that, we're detecting some kind of colors between them. And as you can see, they are most of them are nearly they're super near to 0, and other ones are super near to 255. So what does this mean? When we are looking up at something called RGB, or like, yeah, when we're looking up at RGB color, and let me open this page so we can see it. So let me share this tab. For example, let me change this between, instead of using this, I'm going to use FFFF. So yeah, this stuff too. So as you can see here, oh yeah, are you seeing it? Yeah, I think so. All right. So what I want to say is that here's like our RGB code that we have here. So as we can see here, we have 255, a number that says 255. So what does this mean is that we can see here that there's like this pointer. This pointer is pointing to the white color. White color in RGB is pointed as 255. But if we go to the blacker one, like black color, total black color, we're going to see there is 000 on RGB. So what does it mean? Does it mean that if something is super near like the 0, it is going to be one kind of a black color? But if something is between like something real near to 255, it is going to mean that we're detecting something near some kind of white pixel or gray pixel. So we can see here like the difference of each one of them by just seeing our RGB color, and basically RGB colors of this line are going to be the same one. So you can see how if I move from up to down, the RGB fields are the same ones. None of them are differing. So yeah, this is how we balance like white and black colors by the RGB code. But if I move this to the right, for example, this is going to be changed. I'm going to be changing things. But because we're just working with two kind of colors or one line that determines which kind of color I'm using, this is not going to change. So that is why we're seeing just one number that detects if it is a 0, if it is a 255, 55, and things like that. So if we go back into our collab, we're going to see that into our raw data, we're going to be identifying some kind of colors like 0, 3, 80, 18, 126, and things like that. This means that these colors are kind of black colors, gray colors, white colors that we're identifying, and the complete zeros are black ones. And if we find a 255 one, it means that we're seeing a white color. So that is why we're seeing this kind of raw data. And when we go back here, we can see that we have this kind of numbers that are on our y-axis in our x-axis. This means the amount of pixels that we are using. And remember, we're using images that are 29 by 29 pixels. So in this function, what I'm doing is to try to plot my to plot in a gray map the pixels that I'm looking at. So the only thing that I'm doing is to map or to plot for each pixel that I have. That this means the x train of I, as we saw here, they are just basically numbers, right? And so what I'm telling to this function is, hey, for each pixel that you're seeing in each line that I'm traversing, please in a gray map color in a map of gray colors without interpolation, try to plot that pixel. And that is why we're seeing things like this. Like we're basically interpolating for each pixel that we are seeing like horizontally. We're traveling our vector or our array of zeros and of numbers from 0 to 255. And for each one of them, we're printing out like each pixel that we have here. So I don't know if does that make sense? Like, do you have any kind of questions? Does scale correspond to grade level? Yeah, basically. Then we have to normalize it before proceeding to blah, 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 blah. Yeah, but before going in and getting to that, we're just like showing like what are we looking at? Like we're just plotting the information that we have from the data set. But yeah. Um where are we taking two data sets? Blah, 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 blah. We explained before, we're splitting this data set into two sections, one for training and one for testing. Uh, the one that we're using into our data set is because we need to first train our model to try to make predictions. And after doing that, we need to have some kind of information that is the same information that I'm using for trying to test my model to see if it can predict correctly the numbers that I want to predict. Yeah, we're just doing data visualization now. But yeah, let's just continue with this. So after doing this, we are going to create another code block. And inside this code block, what do you think we're going to do? The only thing that we're going to do is to start preparing our training data. So for doing that, the only thing that we need to do is to reshape the data that we have to something that our neural network can use. So for doing that, we're just going to create a new cell that is going to, well, we're going to take the neurons that are my how can I say it? I'm just going to prepare my image, and this image, let me show you a picture that I have here, and so it can be easier to show you what I'm looking at. So yeah, and I'm going to where was, there you go. I think it was the last one. Yeah, it is. Yeah, sorry for this. So yeah, I'm just going to put here an image that you can see, and let me, yeah, I think now you can see this. So yeah, imagine that this is an 8, and this number 8 is an image of 28 by 28 pixels. But what we want to do, we want to pass this image to a neuron or to a convolutional neural network that can convert this image into a single vector. And what are we transforming this into a 784 pixels vector? We're doing it because we need to change it into a single channel dimensional vector that we need to normalize the pixels. So that is where we're going to transform first 0 to 1 instead of 0 to 255. The thing that who was? The thing that Jackson said. Yeah, sorry for forgetting who it was. But yeah, And how are we going to do that? How are we going to do that, David? So it is super easy. The only thing that we need to do is to add a new line of code, and the only thing that we need to do is to reshape our training data set. So for reshaping this, what we're going to do is to do xtrain that reshape, and after reshaping, we need to pass the values that we want to use. So remember that the first time that we saw the shape of the things that we're looking at, we saw that we have 70,000 elements inside here. So for changing that, we're going to reshape it again. We're going to use the 60,000 elements that we have, but we're going to reshape it into a single vector of 284 pixels. And oh my god, and also do the same thing for the test data. No, I didn't want to do that. We're going to do the same thing for our test data, and instead of doing xtrain, we're going to use xtest and xtest reshape, and instead of doing that, we're just going to use the 10,000 elements, and ta-da. After that, we already have normalized our stuff. Well, not normalized, but we have reshaped our images or our data sets. So in order to scale all the zeros to all the pixels that are from 0 to 255 values into a range of 0 and 1, we can simply divide the array itself by 255. So why we're doing that? Remember that, okay, let me open something like, what's it called? Google what? How is this called? Whiteboard. Web whiteboard. Is it this one? I don't know. So I'm just trying to open a whiteboard on the web, but I think, oh yeah, there you go. Set all the cookies. So yeah, remember that we have like our image, right? And our image have numbers from 0 to 255 values, right? We have values from 0 to 255. So what do you think it would happen if we try to divide, we try to make an entire division of 255 by all the elements that we have for all the pixels that are in each image? So if we make an entire division, that remember on Python, entire divisions are called by 2 slashes. So for example, if we have something like 1, we're going to have 0, that's something, something, something. But because it is an entire division, we're going to round it 0. And we're going to do that for each one of the elements. So it wouldn't, it was going to be the same thing for each pixel. If we have something like, I don't know, 200, and the pixel has a value of 180. Yeah, sorry for my my horrible numbers. But yeah, we're just going to round it by the something that is, we're going to round it to 1 or to 0. But yeah, we're just going to do that for each one of them. So whenever we saw a white pixel, it is going to be a division of 255 by 255. And we are going to pass that, and we're going to have a 1. So that is going to mean that we have a white pixel, and this is going to be the same thing of having a black pixel. So yeah, that is why we're going to do that division by 255. And yeah, until now, do you have any kind of questions? If not, I'm going to continue. So for do that, what we're going to do is to use another thing called as type. So we're going to do that as for changing the value of our training data set to xtrain dot as type, and we're going to pass the type that we want for float 32. And we're going to do the same thing for our test value, test data set, sorry. And we're going to do that. Oh yeah, it's already done. So now what we're going to do is to use a real cool Python tool that we have that is um, equal division to 255, and do the same thing for our training data. Sorry, for our testing data. And what is this going to do is to divide all the pixels that we have for each image in our dataset by 255. So now we're going to normalize that stuff. So what do you think if we take a look into what how we've done until now? So we're going to print again, print training matrix shape. And this is going to be my X train that shape. So let's look at it. So, okay, we have that, and it is 60,000 60,000 by 784 pixels, right? So if we do that, if we hot encode everything, now the shape, now we have seen that the original shape has changed from 60,000 28 by 28 to 60,000 of instead of having an array, matrix of 28 by 28, we have changed it into a single vector of 700 of and 84 pixels, right? So okay, now our data is ready to be used, but let's modify our Y data set as well. So for doing that, what we need to do now is the first thing that we need to do is to notice how the training shape has changed. And after that, as we saw earlier, our output is simply what number an image is, right? So while this is easy for us to understand, machines don't understand this at all. So what we need to do is to categorize each one of these numbers. So for the output of this stuff, what we're going to do is to use one of our NLP favorite. Oh yeah, you're not seeing the top. Yeah, sorry for that. Yes, sorry, so sorry for that. Um, you need to change screen sharing. Yeah, sorry for this. Yeah, yeah. I think yeah, now you're able to see this, right? But yeah. Yeah, now you're able to see it. So yeah, the only thing that we did was to add these two lines of code, the binary code of 255 for like dividing all the pixels by 255, and then we printed out the shape of our data. And after that, what we're going to do now is to do one hot encoding. And if you attended to the previous NLP classes, you will know what hot encoding is. And if not, we can just Google it out. Encoding on images. And yeah, there you go. Nice. So yeah, we can see just what hot encoding as this. So we have this kind of colors, and this kind of colors are, we're going to have an array of colors. And we're in that array, we're going to store each ID. So we can see that we have just 3 different colors here, and the ones are red, blue, green, blue. And well, yeah, there are 3 unique colors, but blue appears 2 times, right? So what one hot encoding does is to create another to reshape this array, or this, yeah, to reshape this array into a matrix that has the IDs and the columns of each kind of color that we're having, right? So we're seeing the same IDs that we're seeing on the first array, and the only thing that we are doing is to activate the ones that are appearing on each field. So for example, on the first field on the ID 1, we have a red color. So because we have a column called color red, we're going to activate it, and the other ones are going to be deactivated. So we're going to do the same thing for the color blue. Okay, color blue appears here on the number 2, but no other color is appearing. So we're doing the same thing for the green one, and we're doing the same thing for the blue one. So we're going to do the same thing for each number that we're going to have inside our array. Okay, so then we're going to go here, side. We're going to go here, and what we're going to do now is that we're going to do our one-hot encoding. So we're going to try to complete our levels to one-hot encoder. So how this is going to look is something kind of like that. Don't worry about it. We're not going to do this. I'm just trying to I'm just showing you what I mean with the one-hot encoding. So if you can see here, we're classifying zeros as arrays who just have an active 1 on the first column, and we're going to do the same thing for 1. All the numbers are going to be deactivated, and the only one who is going to be activated is the one who appears on the position 1, so on for the position 2, so on for the position 3, and so on, so on. So remember, arrays start from 0, so in the number 0, we're activating the position 0, then number 1, we're activating position 1, and so on, so on, so on for each one of them. So yeah, we're going to do that. And how we're going to do that is because what we're going to do is to categorize each one of them from scratch. So how are we going to do that? It is not that difficult. So what we are going to do is to look through all the data, append any unique elements to a list called unique elements, and then for each element of data, we are going to create the same array size of unique elements filled with zeros, and then set the spot corresponding to its index called unique elements. So yeah, I know that that sounds like a lot, but don't worry about it. The only thing, thankfully, we don't need to do that from scratch. But what we're going to do is to take Keras to help us do that kind of one-hot encoding. So what we're going to do now is to take and use into this stuff, and we're going to use the TensorFlow that Keras, that utils, that two-categorical, and we're going to pass our Y train, our dataset, and MB classes. So yeah, and you mean, David, what is MB classes? Where I'm going to use that? So MB classes is the one who we have created just before, but just give me a minute until I'll try to explain that, and then we're going to add the MB classes, all right? So now we're going to do the same thing for our testing dataset. So we're going to use the same stuff for testing, and we're going to use tests here. Oh my God, we're almost out of time. All right. Yeah, we can do this. We can do this. Let's go. So, if you have any questions, don't worry about it. I'm trying to see if there's something in the chat. Blah. Okay. Yeah, it looks like nothing is on chat. Okay, so then what we're going to do, we're going to add this MB classes that is going to be the amount of classes that we have into our classifier. So if we are classifying numbers from 0 to 9, how many numbers are we classifying? We're classifying 10 numbers, right? So this is going to be MB classes, just a number that is the amount of classes that we're, the amount of classes that we're categorizing. Yeah. So yeah, let's just run this out and let's see how we have changed this stuff. So after doing that, the only thing that we need to do is to print out like the shapes that we have just created. So let's see how does the train dataset looks like. So as we can see here, now we have one hot encoded every one of these classes. We know that it's a float30 type. And also, as you can see here, each one of the vectors that we have for each array in the matrix, we already have one hot encoded each one of them. So yeah, okay, until now, everything looks neat, everything looks good. So what do we need to do now? Now we need to build our neural network. And with that neural network, we're going to take a look into a lot of things. But what we need to do now is just to use, try to understand how these neural networks work with a really easy to implement a high-level TF Keras APIs that it has implemented already a neural network for us, so don't worry about it. So yeah, let's just call model. Model is going to be equal to tf dot keras dot sequential. And inside here, we're going to pass an array. And this array is going to have some kind of information that we're going to pass this. So the first thing that we're going to pass is the density of our neural network that we want to build. So this is going to be completed by just typing tf.keras.layers dot dense. And inside here, we're going to pass the amount of the units that we're going to pass is going to be 512. And also we're going to put the input shape that is the shape of the data that we're going to pass. And remember, we're using a shape of 784 pixels. Well, elements. We transformed the 28 by 28 to 784 pixels, right? And just give me a minute. And if you ask yourself like, hey, why are we using like this kind of number? It is just the matrix multiplication of itself. It is like multiplying 28 by 28, and it's going to be like the square of 28. So yeah, it's basically just a mathematical operation, and that is the reason why we're using that number if you have any doubts. But yeah, and then we're going to pass the activation kind of rule. This activation rule is the activation function, sorry, and this activation function is going to be the one who is going to be carrying of trying to understand how we're going to work with a model. But yeah, so I was thinking about one thing, but yeah, basically the activation function is a mathematical operation that we're going to apply to each one of our neurons, and this activation function is going to be non-linear, and we're going to enable it to learn like complete. It is going to be the one who's going to help us to understand this kind of patterns that we're going to have inside our inside of our CNN. So yeah, by doing that, we're going to pass just layers that activation, and we're going to pass relu, which is a function called relu function, and I think you can see it right here. Relu function. It is something like this. So this is the function that we are going to use. Basically, it is like a maximum. And as you can see, we have a lot of activation functions. We have sigmoid, tanh, relu, leaky, high swiss, blah, 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 softmax. So, oh my God, oh my God, it's too late. Oh my God, I'm so sorry. I didn't saw that. We're almost out of time. Yeah, I'm so sorry. We're almost out of time. Oh my God, my camera is super bad. Can you see me that? Yeah. I'm so sorry. Let me search for. Okay, so what we can do is just to try to continue this in other time, because it is almost 7 p.m. here. Yeah, so sorry for that. But yeah, I'm so sorry. Yeah. We can continue this other time. Unfortunately, I don't have any more streams in this local hack week. Local hack, yeah, in this global hack week. So sorry for that. But yeah, it was so nice being here with you. I hope that you learned something today. So sorry that we couldn't finish the project. If we had enough time, we'll be able to do that. Yeah. Yeah. So thank you so much for being here. I appreciate being with you all the time, and I'll see you in other Global Hack Week. And have a nice Global Hack Week. Remember to register in the link. I'm going to pass you the link again so you can register. And yeah, let me pass it through the chat. And thank you so much for being here, Defendant. Thank you so much for being here, Shamari, Sudeb, Ajaxon, Els4, Lahani, Rijoshi. See you, everyone. Thank you so much for being here, and I'll see you another time. So, bye.